Hello, the former president of ISWA. How are you?
I'm fine. Thank you very much for your warm word.
Opa.
My colleagues and all my colleagues in Israel.
So Doron is here, and Carlos is here, and everybody is waiting to hear what you have to say and how we can reinvent the supply chain of waste management. Are you ready?
Yes, I'm ready, and my presentation has been made taking into consideration especially Doron and Amos.
Amos. Okay, they are waving. So let's start. ANtonis Mavropoulos, please.
I'm going to contribute to this event, speaking about the waste supply chain, how it is really reinvented due to the fourth industrial revolution, and what can we do to adapt it better to the emerging climate crisis. First of all, allow me to start by saying something that I'm sure all of us already know. Our world has two promising big trends. The first one is circular economy, which is unfolded as a global wave of change about waste management and resource management. The second one is the huge wave of Industry 4.0, or the fourth industrial revolution. The industrial revolution of artificial intelligence, 3D printers, autonomous cars and drones. The industrial revolution that substitutes not only our muscles, but also part of our brain power with advanced equipment and software. But besides these two hopeful trends, there is a triple challenge that we have to face. And I'm talking the triple environmental challenge that is represented by the huge rise of pollution in a big part of the world, climate change, or more precisely, global warming, and the serious loss of biodiversity. This triple challenge, pollution, loss of biodiversity, and global warming, it's a real existential risk for our planet, for our human societies, at least the way we know them now. I think this is something that more or less became very well understood during the latest pandemics. And I think it's not just by luck, but on purpose, that during the pandemics, we had the time and the attitude to discuss more and understand how we will deal with this triple challenge. And a lot of people, a lot of distinguished scientists, a lot of philosophers, and many politicians, just after the pandemic, they are talking about the need for the Great Reset. They need to reset our economies. They need to reset our correlation with environment and sustainability. They need to reset our societies. And let me tell you this, our societies will be reset in one way or another. They will be reset by the Industry 4.0, by the fourth industrial revolution. They will be reset by the emerging climate crisis. The only question is if we are going to be part and shape this reset, or it will happen and we're going to be victims of our own future. At the same time, we are living the sixth wave in the evolution of waste management. We are living a period in which waste management becomes much more digital. Technologies make waste management much more decentralized and data-driven. What I call waste management is becoming 3D. This sixth wave holds a lot of promises, but I would like to stress here that the sixth wave of waste management will not substitute and completely replace the fifth, the fourth, and the third. Actually, as you already know, a big part of our humanity, more than 1/3 of that, lives always in the first wave, dealing with open dumps and uncontrolled burning. So maybe advanced societies are moving to the sixth wave, but it will be a huge adventure to shift the whole planet above the first and the second one. This is important to consider, especially when you design global policies and global initiatives. Now, there is one thing that is very well known, one thing that the International Solid Waste Association and many other scientists is advocating about it for more than 10 years, one thing that we say in each and every opportunity. What is it? That waste management is probably an integral part of any effort to reduce CO2 emissions. A recent study by McKinsey by September 2021 concluded that the solid waste sector can achieve a 39% reduction in sectoral emissions worldwide by 2030 and a 91% reduction by 2050. But the most important conclusion is that most of this reduction can come to a very low cost of less than $25 per metric ton of CO2 emissions saved. And in some cases in the waste sector, as in the case of landfill gas, this can be reduced even less than $10 per metric ton of CO2 emissions saved. So definitely the waste sector is part of any solution relevant to the reduction of climate emissions. And as I will explain, it can be even more integral part, it can have even more contribution, and it can be a net saver. The fact is that, however, the waste sector is not what it was 10 or 15 years ago. In many countries, the waste supply chain is reinvented. And believe me, it's going to be much more reinvented in the near future. I do believe that the next 5 years will be years of massive and radical change in the waste supply chain. And let me give you some examples or some tips how it will happen. Industry 4.0, the fourth industrial revolution, creates what we call new enablers for better waste management. Either they are mobile phones and software or RFID tags or GPS trackers or mobile readers or any type of sensors. Using these enablers in many advanced societies, in many rich countries, we already observe the rise of cyber physical systems. Systems that are made of smart trucks, smart containers, vacuum systems, robotic sorting, and reverse vending machines. You can say it in another way. Waste management in rich societies is becoming a hybrid cyber, physical, human system in which human behavior is mixed with new equipment, sectors, behavioral analysis, and a lot of data analytics. And this is opening new ways and a new horizon to deal with waste management, not simulating the system, but monitoring it in real time. This is something that we will never be able to imagine it 10 years ago. Together with the enablers, we have a lot of innovation. Here you can see a robot, an MIT robotic boat transportation system that can be used, actually it has been already tested for garbage collection in canals. The picture you can see here is from Amsterdam. This is a new tool that was not available. It's completely autonomous and it can collect more than 1 ton of waste in less than 2 hours. A similar innovation has been done by Samsung. Samsung in its medical center has arranged all the hospital waste management to be automatically arranged by this type of robots you can see in this video. This type of robot is programmed and becomes aware of any waste management activity inside the hospital. It can arrange when the waste needs to be separated. It gives instruction how to separate it, and also it informs the ones that should move it from one place to another to collect it. So there is a robot taking care of all the logistics of waste in the best way possible. Another very serious evolution is the huge increase in the use of sensors in each and every waste management activity, and especially in waste sorting. What do we know till now? We know that sensors, they need to be trained depending on the waste composition for more or less time. We know that sensors, whatever they recognize, they pick it out very efficiently, 10 or 20 times more efficiently than any human sorter. We also know that the big problem with sensors, the problem that we have to solve, is that waste is coming to huge piles. So any sensor requires a big surface in order to operate efficiently. However, right now what we do is that we put sensors to substitute human sorters. In the very near future, what we call a waste treatment facility will be completely redesigned in accordance with the capacity of sectors and artificial intelligence, rather than substituting human work by robots. And this will bring a real revolution to the design of waste management facilities. At the same time, we already observe in many countries what we call the rise of recycling platforms, the rise of companies that develop not only technologies, but also whole new business models and value propositions around recycling. But you have to be careful, because each of these recycling platforms is not dealing with the total waste available. Most of them are very picky, so they focus on specific waste streams that are necessary for their operations, and usually they focus to waste streams that are more profitable, or at least they are paid to recycle. Now, I'm not going to detail about circular economy, but we know very well that in the core of circular economy, it is what we call the closed loops, instead of the linear economy in which whatever you consume finally goes out and become part of the waste stream. Now, what you can see in this graph is how a perfect system of circular economy in textiles, a very realistic one, the one that can be done tomorrow, will operate. What you can see here in this series of arrows is the linear way, and all these loops are the loops that are required to be developed in order to make sure that we will have a circular economy as close as perfect to ideal in the textile sector. Now, the operation of this system depends on the smooth function of 8 different subsystems, which means 8 different markets, 8 different pricing procedures, and 8 different technological linkages. What does it mean? It means that the system moving from linear to circular becomes much more complex. And the only way to deal with such a complex system of 8 subsystems is to make this digital. This is why I always say that circular economy will be either digital or dead. It will not exist. I think this is some tips from the future that is already here, and most of all for the future that it will come in one or another way in many materials in the next 5 to 10 years. Now, a lot of people believe that circular economy is about advancing recycling. That's not true. In my recent book, a book that was published by Wiley Publications in cooperation with ISVA in 2020, we detailed 4 usual misconceptions about recycling. And these misconceptions, unfortunately, they are very widely assumed by people that do not know the details. So everyone that recycles something usually assumes that whatever is recycled displaces primary materials. Unfortunately, this is not the case. In many cases, market conditions determine if this will happen or not. And in many cases, recycled materials are finally moving to the landfills or to waste to energy plants just because there are no conditions or no markets to recycle them. Another misconception is that recycling materials multiple times is better than once. This is also very common, but it really ignores what we call cascading effects and chemical pollution. Another usual misconception is that closed loops are better than open ones. This is a very confusing argument because it ignores completely the cost and the logistics of the closed loops and the energy required and the exact type of materials that should be substituted. If you ignore all of this, you can make a very easy argument like closed loops are better than open ones, but you are no closer to reality unless you define and calculate the cost of logistics, the benefits of the substituted materials, and finally, the energy required for the closed loops. Last but not least, unfortunately, a lot of people believe that recycling is an activity that is always decentralized with small financial cost or even financial benefits. Anyone who is dealing with waste professionally knows very well that the cost of source separation programs and the cost of processing materials are usually 4 to 5 times higher than the revenues from the sales of recycling goods. And in many cases, it's even worse. It's 10 to 20 times higher. But there is this misconception that waste is gold, trash is treasure. And this misconception really diversifies people away from dealing waste as a potential source of pollution, as I will explain in details. It's not that waste does not include value. It is that the value included in waste is very limited compared to their volume. It's also the fact that this value requires a lot of cost to take it out and utilize it. And finally, it's also the fact that dealing with waste primarily means protecting human health from risks, pollution, and long-term effects. And there we come to what I call cascading. Cascading is something very common in recycling. Here you can see a very simple cascading loop for wood. So you start with a raw material, then you recycle it one, you can create high-grade boards, you recycle it twice, the high-grade boards are going to low-grade boards. Then after that, you can only do paper, and after that, not even paper, you have to burn it to produce some energy and create ashes. And this is for wood, a relatively simple material. Things are even more difficult for the composite materials we are using day to day, for the equipment that includes metals, plastics, paper, a lot of chemicals. So ignoring cascading means that you don't deal with real life. Because in real life, the simplest simulation of a closed loop you can have is this one. And if you look closer to this graph, you will realize that if you want to make a lot of closed loops, if you want to make a lot of utilization of end-of-life materials, then you have to find uses and reuses and do a lot of quality control. And as I will explain, mostly you have to remove any type of pollution from the material. Pollution from their use, pollution from their design. And at the end, you have to redesign. So ignoring cascading means that you are talking about closed loops in an ideal world, and in many cases, you are just creating a new illusion to substitute the old ones. Cascading is one of the most important barriers to recycling in each and every material, even to aluminum. Let me give you an example about it. I'm pretty sure you all know that trying to make plastic toys from recyclable plastics recycled a lot of human health risks to children. You know how it worked. We were trying to find a cheap raw material to make plastic toys. At the same time, we were trying to find uses for recyclable plastics, which is not easy. So what we did, we find an easy way to construct new toys because they don't have a specific technical requirement. We can construct new toys from recyclable plastics. This resulted, and I'm asking you to Google it, in substantial health risks that the recycled plastics transferred to children. Risk related with the pollution, with their painting, risk related with their gradual degradation in nanoparticles, risk related with the breath of children. Now, why it happened? It happened because today there are more than 100,000 chemicals in the market. Out of them, only 500 of them are extensively characterized for their hazards and exposures. 10,000 chemicals are more or less well characterized for a small subset of hazards and exposures, and 20,000 chemicals with limited characterization for hazards and exposures, which means out of the 100,000 chemicals on the market, we have 70,000 chemicals with very poor characterization of their hazards and exposures. Every time we recycle the chemicals involved. And if we want a lot of closed loops, we have to remove the chemicals. We have to depollute the recyclables. And then it means we'll create a load of pollutants that we have to dispose of somewhere else. This is why I'm saying that safe waste management in circular economy means that we will need more final sinks and better ones comparing to the linear one. To put it in a provocative way, the more closed loops we do, the more depollution of them is required. And the more depollution means more pollutants will be collected and concentrated, and you have to dispose them off safely for the human health. That means that at the end, we have two types of final sinks for most of the waste. Either they will be landfilled, or they have to be burned in modern waste-to-energy facilities. So let me put it like this. You want a circular economy, you will need more final sinks, which means more and better landfills or more and better waste-to-energy plants, or both of them, as it might be a case. This is why I do believe that it's time to reconsider the waste hierarchy. Here you can see an effort from 2013 to reconsider waste hierarchy in accordance with the circular economy. What you can see in this effort is that there is a new distinct role for waste-to-energy technologies. And we should follow the circular economy approaches and put waste-to-energy after small-scale biomethanization and large-scale anaerobic digestion, below aerobic combusting, but above any type of landfilling, if we are able to do it. And I'm talking if we are able to do it because to implement waste-to-energy plants, it's not enough that you want it. You have to find the way to do it. You have to have the technologies available, the government systems in place, and you have to be able to cover the cost. But in any case, I think that although this effort is far from perfect, it's time to reconsider waste hierarchy and try to give the role of waste to energy the proper role in accordance with the real importance. Now, I'm not going to speak in details, but there is no circular economy without final sinks. And here you can see that when we talk about final sinks at the end, we have to choose. Either we will use sanitary landfills or we will use waste-to-energy plants. I'm not going to say the details, but I'm going to focus on the problems of both of them. The main problem of landfills is that their long-term behavior and integrity is really in doubt. We do know that any containment system in a landfill cannot, and especially lithium collection and treatment, which is necessary to avoid water and soil pollution, is one of the most vulnerable parts on the long term from any landfill. On the other side, the long-term effects of waste-to-energy plants is that we do require the most advanced air pollution systems to ensure public health protection, and we have to find a way for an important for a safe ash treatment and a resource recovery through that. What does it mean? It means that waste-to-energy plants seem a better way to control pollution than landfills, a way that is more based on our technical, mechanical, and electrical engineering rather than the integrity of materials on the long term in uncontrolled conditions. At the same time, waste-to-energy plants seem to be the only way to get rid of pathogens, a very serious health risk in landfills. And it's not by luck that during the pandemic, a lot of the waste-to-energy plants, they were used to burn waste from COVID hospitals, just because they have the capacity to help us get rid of any pathogen. Now, of course, waste-to-energy plants are not perfect. They do require a lot of monitoring. But if we talk about climate change and compare them with landfills, they are by far the best case. Here you can see a comparison between waste-to-energy plant emissions, CO2 emissions, with a landfill gas-to-energy project, with a simple flare in landfill and with a passive system. As you can see, the emissions from a waste-to-energy plants are only a tiny fraction of the emissions of landfills. Of course, this is not the same for emissions of NOx, and where it's comparable, and this is not the same with the emissions from SO2. But if you conclude everything in a single number, dealing with waste-to-energy plants instead of landfills is a much more climate-friendly option. And this option cannot be hidden by arguments. Listen, there is a big debate. There are a lot of arguments against waste-to-energy plants and a lot of arguments in favor of waste-to-energy plants. What I want to say is that for every argument against the waste-to-energy plants, there is a relevant argument in favor of them. And why is that? Because at the end, the problem is not to choose if you like or not waste-to-energy plants. The problem is to put them in the right framework as a part of a holistic waste management strategy and give them the proper role. Restrict them in non-recyclable, in the non-recycling part of waste, feed them properly and carefully with a good design, and make it accessible as a service to everyone through proper financial accounting and cost accounting. One promising feature of the waste-to-energy plants is that they can be combined with carbon capture, which reduces more their CO2 emissions and make them even more climate friendly. However, this is a careful decision that must be taken on a case-by-case condition, because the more you use energy to improve carbon capture, the less the energy efficiency of the waste-to-energy plant. Again, there is no global decision-making on that. You have to do it case by case and find out what is the most preferable solution. Already there are more than 6 waste-to-energy plants combined with carbon capture. The results are very promising, but we do know that the average efficiency of waste-to-energy plants is going down as long as they involve carbon capture. Last but not least about that, I want to put a question that a lot of times is coming to me through people. Why do we need waste-to-energy and landfills in circular economy? At the end, the circular economy, an ideal one, is going to be an economy without any waste. Well, allow me to say that this is completely misleading. And in some cases, it is put by politicians like, can we have a circular economy without any waste-to-energy and without landfills? Let me tell you why it's misleading. In the real world, there is no perfect closed loop. And closed loops are not a condition of the nature, as it sometimes is said. If closed loops were a natural condition for everything, then the evolution of the Earth would not be linear. We will still have the dinosaurs, or maybe not even them. The Earth is evolving through the thermodynamics of it, through its entropy. And the same is happening for each and every product, for each and every human being on the earth, for each and every society. There is a misleading understanding between the natural cycle of chemical elements or pure substances like water and the closed loops of composite products. But chemical elements and pure substances like water have nothing to do with a composite product like a refrigerator or like a plastic packaging or like a car. Nothing absolutely similar on their cycles. And as long as natural cycles are happening for carbon or for water, this does not mean that carbon-made cars or things involving a lot of moisture can be easily recycled, made closed loops. At the end, the discussion and the question if we can have a circular economy without waste to energy and without landfills reminds to me the question, can we have a national healthcare system without hospitals? Can we persuade people to be very safe, very healthy, to do everyday sports and to eat well so we can avoid hospitals? I'm pretty sure all of you realize that there is no national healthcare system without hospitals. In the same way, there can be no waste management system without waste to energy and without landfills. It's all about how you put things in the right framework. And in many cases, the discussion on waste to energy is done in the wrong framework. It's like you are trying to use a tool like this Black & Decker instead of a hammer. You will destroy both the tools. You have a lot of possibilities to destroy your hand too, and definitely you will not gonna do your job. So putting things in a systemic and holistic perspective can find out the solution required and the role for waste to energy, landfills, or any other thing in circular economy. I'd like to finish with 3 thoughts instead of conclusions. First, we know well that improving waste management can provide net CO2 savings, can be done through a lot of commercial technologies available right here, right now. It can be done in affordable cost, and it can have a fast delivery of CO2 reduction. So the waste management sector is becoming the most important immediate use sector to reduce CO2 emissions. Second, we know very well that circular economy is a condition to manage global warming. We need 3 billion tons of metals and minerals by 2050 to scale up wind, solar, and geothermal power and deploy energy storage, electrical cars, and all of this if we want to keep the rise of the temperature below the 2 degrees Celsius. These 3 billion tons of metals are simply not available by mining. Either we will recover 30 or 40% of them through circular economy practices, or we will not achieve the Paris Agreement targets. In this way, the shift to circular economy is a much broader and wider condition than fighting global warming. And it has to be like this, really upgraded in the global agenda. Last but not least, changing waste management, changing the recycling markets, making closed loops will create a lot of domino effects. And these domino effects can really deliver savings of more than 1/3 of the total savings required to achieve the Paris Agreement targets by 2050. Let me finish with this. The waste management sector is a very, very small sector in the global economy. In this graph, you can see that the size of each year is relevant to its economic size in the global economy. However, this small sector can act as a catalyst to deliver wider changes, to inspire, change the reality, create new products, and develop circular economies on a global and local scale. And this is, I think, our best ambition, that the waste management sector will be the catalyst for a broader change and shift to circular economy. Thank you very much.
Antonis, Thank you very much. I'm sorry, but the clock is running. So first of all, I would like to thank you on behalf of all of us. And I guess that during the break, we will collect questions for you. And you'll get back with answer for the next session, if it's possible, because people here are starving, thirsty, and I'm sorry for the delay, but it was good to see you. Thank you.
Thank you very much.